today we're going to be talking about sex-linked traits. Remember, you have a question. I will test you on sex-linked traits stuff tomorrow. Now, a couple of things. If you're a girl, what do you have? XX or XY? XX. If you're a boy, you have XY. Hopefully from that activity, you have remembered that really, really well. Looking at this diagram right now, what can you say right off the bat about these two kinds of chromosomes? What can you say right off the bat? Yes.
The Y one is very small.
The Y one is very small. Yes, the Y chromosome is a lot shorter. Now I'm trying to look. I remember there is a Human Genome Project poster somewhere in this room. I think I see that one over there, but I don't see any more. Either way, the Y chromosome is a lot smaller. So in this case, it carries a lot less genetic information. It'll carry a lot less genetic information. But basically, what makes a guy is here. But now, in our cases, when we're talking about sex-linked traits, in all high school syllabus, in every single high school syllabus that I've encountered, Ontario, Quebec, AP for American, IB or A level, when they talk about sex-linked trait, they only talk about the sex-linked trait that are on the X chromosome. And so will we focus on that, okay? Yes, there are sex-linked traits that is on the Y chromosome itself. And those sex-linked traits that are on the Y chromosome will be exclusively passed down from father to sons and not others, okay? But if it is on the X chromosome, it can affect everyone. It can affect everyone, okay? So we're going to be focusing on the sex-linked traits now. Keep in mind this is being recorded. I'd rather you pay attention, focusing. Now, so these are the three sex-linked traits here. We're going to be focusing on these two: red-green color blindness and hemophilia. Both of these are sex-linked recessive traits, okay? Sex-linked recessive traits.
Wait, so what about the last one?
The last one, just know that it is there, okay?
But would it be recessive or?
It would also be recessive, yeah. It should. So in this case, now keep in mind, we're going to use red-green color blindness here, for example. Here are 5 different outcomes. Okay, 5 different outcomes. You can have now we're going to use R because red starts with R, and big R and small R look sufficiently different. Okay, so big R will be for normal vision. So XR or X big R, that will be a normal vision female. And X with big R and a Y, that will be normal vision for male. Okay. Keep in mind there's nothing on the Y chromosome because this gene is only on the X chromosome itself. So you leave this spot here blank. You could have X small r, that will be an affected female. You can have an X small r and a Y, that will be an affected male. Now, because this is a recessive trait, you can have X big R, X small r. So in this case, you have a carrier, a female carrier. She would not have color blindness, but she would be carrying that gene or that allele. Okay.
The last one?
Yes, this will be a carrier female.
Excuse me. Sorry.
Okay. So make sure you have that. Again, you must, in terms of doing problems, you must include the Y there. You must include the Y there and make sure that it's blank on top of the Y, okay? By the way, just a quick survey. Any of you, if you don't mind self-disclosing, are colorblind in this class?
My dad is.
Your dad is, okay. Any of you know someone who is colorblind? Who? Sorry, say again? Who? Simon? Okay, so that's a boy. You know, but is that the only person? Another boy, okay. Who?
Joseph Pye,
Okay.
age 12. He has red and green colorblindness.
Oh yeah. Yeah. I taught him last year. Yes. Two males, okay. Yes. What? One of your aunt. Oh wow, okay. Anyone else? I'm curious, does your aunt have any kids? Any boys? Do they have color blindness? They don't. Interesting. Okay.
Mr. Richards.
Okay. Someone else also mentioned about this teacher. Okay. Now, just a quick survey here. Yes, it's a very small sample size. Okay, 10-ish people, but it's predominantly male. I know of two other people who are colorblind. One of them was a former principal of mine, which makes it very interesting to enforce dress codes. And to another student who didn't tell me that he was colorblind until the end of the year. So, so in this case, it is a condition that mainly affects males. Why is that? Looking at the chromosomes and think about why that would be the case. Yes.
Yes, we only have one X, and then if that one X, you have 50-50 chance pretty much.
Okay, that's good. Boys have only one X chromosome. If that one X chromosome have that allele, have the recessive allele, then he's stuck with it. Okay. For girls, there's two X chromosomes. So if one of them have the recessive allele, hopefully the other one will have the dominant allele and take over. Okay. Good. So for sex-linked trait, you will see that it's predominantly, at least in our textbook, or at least the ones that we are looking at, will only predominantly affect males. Okay? Good. So let's do this question here. Yes.
Are there different types of colorblindness?
Yes.
And how would that work with the chromosomes?
I'm not sure.
Oh no.
Okay, so sex-linked trait problem. Colorblindness in human is an X-linked recessive trait. What's the probability of a couple having a child that is colorblinded if a man is colorblind and the woman is heterozygous for normal color vision? So in this case, the man, what will be his genotype? Yes.
Capital X with capital R, and then.
Are you sure it's capital R? He has color blindness.
Oh, sorry, lowercase.
Lowercase r and
just Y.
Y. Good. And the woman would be,
XX with capital R and lowercase.
okay, so that would be the situation, okay? Always write out, especially on these conditions where there is an established way to show, make sure you write them out. Yes.
For the woman, yeah. Could we have two uppercase R's?
Here it says
Oh, it's
heterozygous.
Okay, I didn't
Yeah.
know that.
No problem. So in this case, that will be the cross. I would say a good number of times when students make mistake, they make the mistake here. Either they didn't read the question carefully, or they forgot that, oh, it's a sex-linked trait. I have to put an X, Y, X, X, and put the letter on the X only. Okay, a lot of people put something on the Y, and that's wrong. Okay, don't do that. Yes.
Just a question. I forgot to ask this before, but when we're doing Punnett squares, like the monohydrate ones, like, is there a side that the father should be on and the mother should be on, or it doesn't matter?
Different textbook do different things. I want the dad to be on top, mom to be on the side. So if everyone's doing it the same way, it's a lot easier to check. Okay. So in this case here, if there's a male and female condition, you put a male on top and female on the side. So in this case here, X small r and Y on top here, X big R, X small r on the side here. So you filled out this Punnett square. Okay. So in this case, remember, Punnett square is to help you calculate probability. Okay. So out of four possible outcomes, what would the question is asking? The probability of having a child that is colorblind. So in this case, out of four possible outcomes, which outcome have colorblind children? Yes. The two bottom ones, these two. A colorblind girl and a colorblind boy. Okay. So in this case, you have four possible outcomes. You have two outcomes. Okay. So in this case, two colorblind children out of four possible outcomes. Okay. Yes.
Will this be like what will have to be tomorrow?
You will have a sex-linked Punnett square. It could be this one. It could be that some other one. It could be something with a little twist onto it.
So tomorrow's quiz is just doing a Punnett square in 10 minutes.
2 or 3.
Okay.
That's 10 minutes way too long. I'm not helping you by doing that. Okay. So in this case here, because they didn't quite specify probability, what form they want it in, I would show both. And please do circle your final answer. So I don't need to go look for which number is which. If I have to go look, you're losing mark. Okay?
Wait,
So-
Mr. Chen, when you say it didn't state which they wanted specifically, does that mean you want us to have in a percentage and a ratio?
Percentage or fractional ratio, yeah. If they specifically say probability or in a percentage, then do percentage. If they ask what is the ratio of colorblind children to normal vision children, so it will be 2 to 2, then it will be 1 to 1 ratio. But always reduce if it is fraction or ratio, and if it is percentage, just give it in percentage. Yes?
What did you say we shouldn't do? Like, before?
You should always circle your final answer, so I don't have to go look and guess. Okay. And again, read the question. If they ask for ratios or fractions, then always give the ratios or fraction, but in the reduced form. Okay. Any questions on this? Yes.
Do they use a Punnett squares to figure out the traits of a parent?
That is a possibility, yes. You can do it backwards, but you have to have enough information about their offsprings first. Good. You know, the more ideas you give me, the more interesting my quiz will be, eh? Are you guys good?
Yes.
Questions? Now, because we have time and this other thing, the other one that we're going to focus on, hemophilia, is very, very interesting. So we're going to talk a little bit more about that. So grab a blank sheet of paper right here.
Oh my gosh, I got a master plan going on. Okay, so this week I'm just gonna put us together. Okay, but the thing is that it went good. Like, he dropped me like half the room, and then his mom.
Oh.
Yeah. Okay. Yeah. And the thing is that we use this for
He always has like some guys.
Yeah. Right? I would show you the best friend too, but like that's obviously impossible. Like that is his main best friend. His best friend. No.
Okay, so hemophilia. Hemophilia. Hemo, it means blood. Philia means love of or like. So hemophilia means like blood. It's really a weird naming because people who have hemophilia is not like they like blood. It's the fact that they can't stop bleeding. They have a difficulty to stop bleeding. Okay, because of the clotting factor, one of the protein on the clotting factor doesn't work. It's defective. So that's a problem.
Wait, Mr. Chen, why is
Yes. Yes. Okay. Yes.
Is it related to the hemoglobin?
Yes. Well, because it's not necessary. The condition is not related to hemoglobin, but keep in mind, hemo or hema, it's basically the root word for blood. So hemoglobin, this protein that is on related to blood. Okay. Yes. Is it the absence or is it the defective form? I don't remember. I have to look it up. Okay. Usually, that's something that I would teach in when we're talking about clotting cascade. But I don't think that's a great. I think that's a grade 12 topic. Yes.
Why is it that some heart patients, like, if they like get a cut or something, then it's really hard to stop? Does it have anything to do with that?
If
Like people who take a bunch of like blood pressure medication.
no, that's because they take because they take blood thinners. So blood thinners means their blood is thinner, and so in this case, the amount of like clotting factor, platelets, and stuff like that will be less, will be more diluted. So in this case, it will be harder to stop the bleeding. But this is this have nothing to do with it. This is a genetic condition. Okay, it is a genetic condition. Now, this is also a very, very famous genetic condition. Anyone want to guess why? Yes.
Was like a long time ago, where like disease and not disease, but where like people that died because of.
Okay, not necessarily just because of that. You put your hand up next.
I can't remember the names, but in World War II, someone's son had this, and then they were with Rasputin.
Oh, okay, good. Okay, so we'll mention that and link back. What are you gonna say?
I was gonna say some sort of dude. He started cut and then started bleeding like crazy.
Well, I'm pretty sure if it is a regular person, it might not be causing this condition to be so well known. How many of you know who Queen Victoria is? Who is she?
A queen.
of when?
For Queen Elizabeth?
1922.
Before that.
Way before that. So I think.
Isn't she like the
Queen Elizabeth
So-
Didn't she?
Do I have the family tree here? Yep, I do have the family tree here. So in this family tree, Queen Elizabeth is here. Queen Victoria is one generation back, 2 generation back,
Wait, David.
3 generation back, 4 generation back. So she would be Queen Elizabeth's great grandmother. Yes.
That's good.
Is this a genetic bottleneck? Because
I'm
would they
not
have
sure.
a genetic bottleneck?
What do you mean? In what sense?
Because genetics should be stagnant.
What do you mean? Genetic would be stagnant if you're talking about like.
It's like, you know how certain traits will keep on it keeps on repeating and the genetics are not as diverse. There's
Yeah.
Some disease to be more common.
Yeah, we're not talking about that.
Basically, the king was friends with Rasputin, and then they were like, "Oh, Rasputin's magic. Let's invite him to heal our son." And then the theory is that Rasputin took the son off his meds, so the son healed, but he still had him.
Damn.
Okay, so since this person's brought up, so let's do it this one.
Is it like Rasputin and that like
I forgot the name of the king.
Yeah, that was the Tsar.
Like, I'm not gonna
I think Tsar Nicholas,
Yes.
right?
Wow, you remember this name. Okay,
King's Pass. No,
come on. No,
Just zoom in or something.
no, that's
No, open that in new tab.
Yeah, yeah. But just that's Rasputin. Yeah, that's the one.
There you go.
Yeah.
okay. So let's zoom in a little bit. So Victoria, Queen of England, back in the 1800s, early 1800s. She has the reason why going back is so famous because she is a carrier of hemophilia. And guess what? She also were very fruitful and productive. So 1, 2, 3, 4, 5, 6, 7 kids.
Yeah.
And because back in the day, royal family marry other royal families. So in this case, her 7 children, this, and yeah, they were married into other royal family. And with this match, Alice produced this girl, can't read her name, which is married to Nicholas II of Russia. And because of that, you have this, I'm not sure what's the title, but Sartis. Alexis, the youngest son, Alexis, have hemophilia, and that leads to the whole Rasputin, and that might be one of the causes of the revolution in Russia. But anyways, how biology affects world history. Anyways, coming back. So coming back, don't give up yet. Okay, wait for 2 more units. Anyways, coming back. So as you can see, because of her, it is a very classic textbook, well-studied scenario. So basically, it is again on the X chromosome. So if you have a big X with a big H, you have a X chromosome with healthy clotting factor. But if you have a lowercase h, you will have a defective or hemophiliac clotting factor. Okay, you would have a hard time stopping to bleed. Once upon a time, I had a student teacher, and this student teacher was not a young person. He practiced as a dental surgeon for a good number of years before he decided to go into teaching. So there was this person who had way more biology background than I did. And I asked him, it's like, so when you go to a dentist, you bleed pretty easily. Like, anything, your gum will bleed very easily. So what do you do with someone who have hemophilia? And he said, well, if any time that we deal with a patient that has hemophilia, whatever we do it in the hospital, just in case. If we can't stop the bleeding, at least you're in the hospital, there are medication or equipment to help. So in some ways, something as routine as going to dentist, that becomes like, wow, you have to go to the hospital for that. Okay? Yes?
Is there a condition called hemophobia?
Not that I know of.
Repulsion to blood.
Yes, when
Oh
you-
my gosh, that'd be bad.
Okay? Yes?
So I think a person with hemophilia would like start bleeding uncontrollably if they even got like the small
Yes.
paper cuts.
They would have a hard time stopping bleeding.
Would it like if
It is a life-threatening condition.
like a paper cut?
I don't know what depends how deep your paper cut is, right? Some paper cuts is like, nah, you don't see any blood at all, and some paper cuts is like, you actually bleed. Yes. Hemophilia and on blood thinner. Chances, I hope the doctor will think twice before prescribing blood thinner. I think that is that would be tricky. That would be dangerous. Yeah.
Would it be a blood thickener though?
No, they would give because it's the clotting factor that's not working. One of the things they'll do is they'll just get the synthetic clotting factor. They'll add that in or some other things.
Oh,
Okay. So again, male, remember to use the XY chromosome and only put the letter on the X chromosome. Okay. Don't be lazy and say, oh, we'll just ignore the X and Y and just put H on whatnot. That's one easy way to make a mistake. Okay. All right. So let's say we have this situation, and since we counted her offspring 7, okay, she had 7 children. My goodness. Well, it was 1800s, so it's a different scenario.
Oh, yeah.
So Queen Victoria, Queen Vic, is a carrier, as we saw earlier, and Prince Albert, healthy male, has 7 children.
7? Oh.
We counted earlier. What are the chances of healthy children? What are the chances of affected children? It's a poorly worded question if I'm asking for like the probability with the 7, but yes.
for example, if with a mother that has hemophilia, like if they had a son and like the father didn't have hemophilia, would the sons be more likely to have
Are you sure?
hemophilia?
Sorry, repeat the scenario again.
So I need two cases, but like in the first case, the mother has hemophilia and the father doesn't. The second case is the father has hemophilia but the mother doesn't.
Okay.
So in the case where the mother has hemophilia, would it be more likely that like male offspring would have hemophilia in comparison to like the one where the father has hemophilia?
Okay, good question. Now, let me ask you this: for a boy who only have X and Y chromosome, who gave him the X chromosome?
Is that mom?
Mom. Okay. For a boy, the X chromosome is always from the father. No, Y chromosome is always from the father. X chromosome always from the mother. So if the mom has hemophilia and she has sons, all her sons should have hemophilia. Okay? Because the mom can only give X with a small h. Okay? Now, if the dad has hemophilia, remember the dad can give an X with a small h and a Y. So in this case, as long as the mom is not a carrier or doesn't have hemophilia, pretty much all her sons would be healthy if the mom is not a carrier. Okay? If the mom is a carrier, then the daughters would also have a chance of being hemophilia. Okay, so I think you guys finished copying that down. So Prince Albert, what kind of lettering would he has? Genotype would he has? Yes.
X, big H, and Y.
Good. And Queen Victoria?
X, big H, X, small H.
Good. So you have that. Now, so you fill out the Punnett square. Again, please have the dad's information on the top and mom information off the side, and you should have this. Okay?
Dad's information on top.
Yep. Dad on the top, mom on the side. Okay, so in this case, out of 4 possible outcome, how many possible outcome for healthy? And when I say healthy, that includes carrier children. 3, including carrier. So healthy, carrier, but we're counting this one. So 3 outcome out of 4, and you have 1 outcome out of 4 that is affected children. Now, remember, she has 7 kids. If let's just say her first kid has hemophilia, does that mean she will never have kids that has hemophilia? No. In terms of probability, and if you take data management, hopefully you'll remember this next year. Every time there's an event, the probability is like basically you have to count it again. So for every child, they have 1 out of 4 chances having hemophilia, 3 out of 4 chances of healthy and carrier. Okay. And if we're looking at this compared to the family tree or the pedigree chart that we saw earlier, I think she was pretty lucky.
Does that say healthy carrier?
Healthy and carrier. Healthy and carrier.
Can we write or?
Sure. Healthy or carrier.
Should we include 1/4 chance of
infected children, or infected children.
You can do that. Yeah. So again, circle your answers so I know that's your answer. Okay. I don't need you to do grass or grasp way of showing work, but at least circle your answer. Okay. Are you guys good? All right. So there are some practice questions. Yeah, let's look. 1, 2, 3, 4, 5, 6, 7, 8. Whoa, did I miscount? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 kids. 9 kids. So it wasn't 7. Out of 9 kids, only one child, Leopold, has hemophilia. Could have 2, or could have more. So actually relatively lucky. Okay. So now there are some practice questions I am asking you guys to do from the package. I'm still adding questions. So let's see. Number 10. So when I say page number, I'm talking about like this is page 1, 2, 3. Okay. Page 3, bikini bottom. 4, 5. Okay. 6, 7, 8, 9. 10 is a test crossing and blood typing. I should give you some blood typing. 11, 12, 13, 14. Sorry. 11, 13, 15. Ooh, this is a good one. I like these questions. These are fun. Number 14. Okay. So page number 14, this is a blood typing one. And I should give you some that has
Okay, whatever.
I have faith in you. Like, I just
Okay.
okay. So do these questions for now. Okay, that will be your practice questions.
That's what everyone told me.
Oh yeah, wait. I should give you a sex-linked one, so you don't just see it and don't practice. Okay, so I will also ask you the sex-linked one, which is what we did. So 15, 17, 19, 21, 23, page 25, and let's do a blood. Okay, this one, problem set, lethal, alleles, sex-linked alleles.
Okay.
Okay,
I think I should.
number.
Yeah, that's what literally so I went to my friend and literally she was like right like the house. He's like, girl.
Let's do number 1 and 5. Okay, so That is a fair bit of questions. Okay. But again, if you do them, you will do well on the quiz. Any questions? Again, key to success to this is do a lot of practice question. Okay. All right. I will see you guys tomorrow. Get ready for the quiz.